So as Caitlin mentioned, I was here last year, so it's a bit of deja vu, very similar outlook, except this desk was on the other side, so it's a bit confusing, but I can handle that. So there's also a bit of a different atmosphere and vibe last year. So WeAreDevs Congress Vienna last year actually had a little tagline. It was called the Artificial Intelligence Congress. So it's a bit telling, like, I think it's sort of taken for granted now that artificial intelligence is just part of our life as developers. It's part of the infrastructure that we need to deploy. It's part of the infrastructure that we rely on. And Ocean Protocol is really there to kickstart that or orchestrate this AI economy or data economy. So that's sort of one tie-in. The other interesting thing that was happening last year, if you recall, is that we, as EU citizens, sorry if you're from the US or outside of the EU, we actually got a set of new rights as citizens in the EU. And that was GDPR. And there was definitely a different atmosphere and vibe because during the lead up to GDPR, there was a lot of people panicking a little bit, like, this is going to break the internet. And in a way, it did. You'll notice you have a lot more little things to click on to get through to your actual website. So that was another interesting thing. I don't know if anyone's actually exercised any of those rights. Anybody tried that? Right to portability. Have you downloaded your data from Google, for example? Yeah, so it's really interesting. So you'll get several gigabytes of data. It's going back to when you first created your Google account. And you'll find some really interesting things, your entire search history, your entire location history. So this is all sitting on a Google server. You could also tell them to delete everything. So that was sort of going on last year. And that ties in also to Ocean Protocol. So who owns that data? And what is that data worth? What do you think? Like, any ideas? Like that 4 gigabyte file that sits disparate over different servers on Google, what is that actually worth? There's no real clear-cut answer to that. So Google probably knows, but we don't know necessarily. So there's no real market value. So that's one way to consider the worth of something, is what is someone willing to pay for that? And there's this missing component, and that we can call that the data economy. And that's part of the motivation of Ocean Protocol, to kickstart that economy. So just a very brief slide on history. So Ocean Protocol is a nonprofit foundation. It's registered in Singapore. And BigchainDB is a for-profit company based in Berlin with a long history in blockchain, actually one of the very early blockchain companies. And that was kickstarted with Ascribe, which was ownership of rights to artistic works on the blockchain. And that's actually programmed in Bitcoin, because Ethereum wasn't really a thing at that time. And then it shifted to database technology on the blockchain. And finally, there was a pivot most recently to Ocean Protocol, which is the key project right now at BigchainDB. And so, yeah, so we supported Ocean Protocol Foundation to launch an IEO in May. And yeah, we went into production this summer. So I'll give a quick demo of that as well. So the data economy, I've already talked a little bit about this. We know that it's huge. We know that it's growing. We know that it's growing very quickly. And I mean, you can't really say much more than that. We know that it's huge, but how huge? There's no real concrete numbers. There was a study in 2016. So let's say maybe it's €1 trillion, more or less, plus minus. It's really, where do you draw the boundaries to this economy? And how do you measure it? We don't really know. So that's an interesting thing that's missing, this type of information. So it's comprised by a lot of different data processing and storage, collection. It's really a question of where you draw the boundaries. So in this data economy, which is in its early days, there are several problems that we're addressing with Ocean Protocol. One of them is how to connect owners, problem solvers, and the resources to actually solve those problems. So we can imagine, for example, a hospital with genetic data and researcher in maybe a different jurisdiction who is an expert at researching Alzheimer's. And then the problem, of course, is we want to save lives and improve quality of life by researching the genetic markers which could lead to Alzheimer's. So how do you connect these people together if they're in different institutes, different countries. That's one challenge that we have, which will kickstart this data economy. So this will create transactions, which could be a problem solver setting a bounty to solve a problem, and then the problem solver, which would be perhaps a data scientist or a genetics researcher, who would then take this bounty and then try to find a data set which would create another transaction or create a trained model which could then be sold. And this whole transactional nature of the data economy is one of the challenges that we're looking at. The other aspect, especially in this case, so I gave a very extreme use case. I was talking about genetics data, which is the most private data you can imagine. And of course, you can't just put that up for download on a website. There are huge legal and privacy concerns. So the question is, how do you unlock access to this data? And there are many other grades of security and privacy. Of course, you could consider customer data, but there are other reasons why you wouldn't necessarily want to download that data set. It could also just be so large that you wouldn't want to run it on your premise. So this is the big picture, is that we want to create this ubiquitous infrastructure. So blockchain and smart contracts are a way to create this permissionless, unstoppable infrastructure. So that's the way it's evolving, is that this blockchain we can consider as part of the stack, as part of the infrastructure that you can rely on. So instead of pushing it to the cloud, you can push it to the blockchain. And the interesting thing is that those smart contracts will keep running forever, essentially. As long as there's enough incentive and interest in mining, those smart contracts will keep running forever. So they're unstoppable. They're also ubiquitous in the sense that you can't censor them. So I'm also anticipating the question, like, why blockchain? So this is one reason. So the second thing is we want to, the challenge is how do you access this data? So as a data scientist, we want to connect the algorithm, we want to run it on some compute instance, and then we want to bring the data. So the data has to eventually get into memory of that compute instance to generate some training and some updated weights. So our idea is that we want to send the algorithm into the premise where the data exists. That's also interesting from a GDPR perspective, because who now is the data processor in this case? We would argue that that would be then the data owner. So that would be, it's not, of course, legally validated, but that's the premise. So that would be access control and verification orchestrated by the blockchain. And there's a bunch of reasons why the blockchain is a great choice for doing this type of activity. And then, as a data scientist, of course, I'm also considering not just the data economy, but the AI economy. So what is that? It's even further down the road, so it's even a bit more amorphous. But we know that the AI economy is driving the data economy. Why? Well, we know that this early study, for example, proves that more data equals better results. So should you invest that next 10,000 euros into hiring more developers, more data scientists to improve your model, or should you just go out and collect more data? The answer in many cases is you should just go out and collect more data and just keep that same algorithm, but if you pass more data into that, the results will drastically improve. And that's particularly the case with deep learning. That's a very, very data-hungry algorithm. So there are other, of course, major challenges, which could be solved by some type of orchestration layer. So productionization, assigning rights to the results, the whole legal liability. There are a lot of challenges coming up. And then even a step further, so it's not really, for me, it's not just an economy. It could be something like an ecosystem. So an ecosystem could involve automated algorithms which, so you're not training the AI model, but maybe some agent is training that algorithm. And that agent is incentivized to increase the accuracy. So it's going out looking for bounty. So it's a sort of a meta AI in that sense. And we need to connect all of these different providers and problem solvers and players together in some fashion. And we don't know what that looks like. But the Ocean Protocol thesis is that we need to make it open source. It needs to be community owned. It needs to be permissionless, uncensorable. And that is the alternative to having all of your services running on the cloud. So instead of being vendor locked into AWS or Google, and it's a huge topic right now. So there's a recent, very major EU political motivation to create a European cloud. So it's not just theoretical. There are real moves currently. So there's a German-funded project called Gaia X, which is exactly for this purpose, which is to create an alternative. So let's say that suddenly there's a trade war between the EU and the US. Maybe not so hypothetical in current climate. But what if during that trade war we're throttled on our access to the cloud? So all these servers sitting in Silicon Valley, that could be a major risk, economic risk and strategic risk. And therefore, we want to look at alternatives. And we're part of that working group called Gaia X, which is now moving to incorporate France and finally the EC. So that's the overall picture. The other thing is that there are a lot of data breaches. So it's also a question of who do you trust with your data. And again, this is also, of course, a legal issue and a security issue. So what we imagine is that you own your data. You should keep your data on the premise, and you have control of that. Other things you can do, of course, encryption. So yeah, let's get into some details. That's the overview. Now let's take a look at what we've built. So the first thing is a very, very brief slide on architecture. So we have the end client, which could be a command line interface or a front end, which I'll demonstrate. So that's the user. And they need to interact with Ocean Protocol. And Ocean Protocol is comprised of several different components. The first and foremost being the blockchain nodes. So we're running a proof of authority Ethereum blockchain. It's also on the mainnet. And currently, we're running the nodes ourselves. This is not the long-term vision, of course, so we're onboarding node operators. We want to make this decentralized, of course. And we're running the parity secret store, which enables us to encrypt securely the certain aspects of your data set, which describe the asset. We have a metadata store, which is describing the underlying data. And we have this cloud service manager is acting as a proxy and an access control layer. So these are all the end components. And then in the middle, we have a Java, JavaScript, and Python API, which is all synced up. So you can interact with this in your language of choice. And I'll demonstrate the front-end component in a second. So this is what a static asset looks like. So it has different views. You can look at an asset in different ways. You can look at it on the blockchain. And on the blockchain, we're storing the primary key of the asset, or the ID, or the name, or whatever you want to call it. It's called a DID. It's a decentralized identifier. Think of it as a URL. This is a standard, Web3 standard, which is very recent that we've employed. We store the owner of that, and that is then strictly enforced on the blockchain, of course. So that means if you have the private keys to that public key and that public address, then you own that asset. That's the owner, period. No questions asked. That's cryptographically enforced. And the hash of that asset. So that means that if you download that data set, which is not stored on the blockchain, by the way, the data set can be stored anywhere, essentially, because, of course, you can't store a gigabyte of data in Ethereum. But once you download that data set, you can check if that data set is actually the same that you wanted. You can check against the hash and say, OK, this is different, therefore maybe something is wrong. So the other view would be the metadata of this asset, this data set. So that would be the title, the categories, maybe some sample data. And that is then linked with the DID. And then finally, the data has to live somewhere. So we support storing the data on-premise, on the cloud. So we support drivers for S3 and Azure. and IPFS as well. So we can also consider the data to be stored in a decentralized infrastructure as well, which opens up a lot of interesting possibilities. So I'll give a quick demo. So this is our DApp, our decentralized application. And this is one of our test nets. So we do have also on the main net a production network where you can actually set a price on a data set. This is just a demo marketplace. So of course, the big picture is that you should be able to, first of all, take this demo marketplace. You can fork this. You can take our GitHub repos, change the logo, and run this yourself. And then, boom, you've got a marketplace. You connect to our network. And you can then start earning tokens, money, based on this publish flow that I'll demonstrate. So interesting thing here is that I've got a default temporary blockchain wallet. So we notice that a lot of people that would like to publish data sets, and for example, data scientists don't have time necessarily to understand blockchain. They don't know what MetaMask is, which is the open my console there. So MetaMask is a plugin for the browser, which allows you to, it's a wallet, it's a blockchain wallet. So a lot of people don't know what that is, and they don't necessarily want to know what that is. So that is why we have this temporary wallet, which is your temporary blockchain identity. But of course, if you want to actually earn rewards, or if you want to access priced assets, then you would use your own wallet for that. So we're connected to these different components, and we'll take a look at the landing page. So we have a bunch of data sets, and I've done a bunch of test data sets here as well. So we have different channels, so we can also search, and I published one which is related to the Amazon deforestation. So I published a notebook, I published a pre-trained model, and the data itself. We can look at this. So this is the metadata. This is stored in Mongo or Elasticsearch. So that's what I mean when I say metadata. That is the category, some description. It supports Markdown. And then finally, the actual files themselves. And we can then go ahead and ask for that. And that's going to be, if it's a priced asset, it would ask you for confirmation that you would be willing to pay for this data set. So while that's running, I'll now go ahead and publish an asset just to demonstrate that part. Go over there. So I've got just some Kaggle competition I'm working on, so I want to publish one of these files. So we'll just say test asset. And I want to add it to IPFS. This is now fully integrated, so we're running our own IPFS gateway. So you don't need to host this. So of course, eventually this data needs to live somewhere so that people can download it. And currently, we support, like I said, S3 and Azure. And in that case, of course, if you want to host it on S3, that means you need to make an S3 bucket. You have to upload it to S3. You have to make sure the permissions are set properly. And of course, that's something that is time-consuming. And if you don't have a data engineering support, that might be a bridge too far for you. So now we also allow you to host this on IPFS. And that's just a drag and drop. So I'll just make a description, select one of the categories. And again, like this is all just our demonstration marketplace that you can go ahead and fork, and you can run that yourself. So you can change your logo, and you can be up and running with that very quickly. So let's put my name, test, whatever, and choose a license. So let's say it's a public domain, and then register. So what it's doing is it's going to encrypt certain aspects of that metadata. It's not encrypting the actual files in this case. It's encrypting just the pointer to the files. So that means that you won't get, for example, DDoS attacks or people trying to hack into your S3 bucket. And that's going to be decrypted by the proxy server itself. So while that runs, I'm just going to go back to the presentation, and we'll come back. OK, so just to wrap that up. So what we just did is we took a data set and we published that into Ocean. Essentially, that's what we call publish. So what does that mean? that means we've instantiated this thing into the blockchain, and actually that is primarily the decentralized identifier, which is the primary key, and that's going into a smart contract mapping, which points to the owner and the metadata itself. And that's metadata is called the DDO, and that's part of this Web3 standard. That's the DID description document. So we've published the data, but actually we could also very easily publish other types of static assets. That would be different files, for example. That could be my model pipeline. So I could publish my Jupyter notebook or my R script or some other data science algorithm. I could publish that as well as a file. I could also publish the result of my training. That would be the trained weights file. So we know that that Google, for example, offers some of their models for free. For example, recently was released the GPT-2 NLP, so the NLP deep learning weights file, which is a deep learning network for embedding words and making predictions about natural language processing. But actually, this type of deep learning models, they're very, very expensive to create. So there are probably other types of models and other models sitting around that we would like to gain access to. And the only way to gain access to them is if you incentivize people to make them available. And that's part of the key of this data economy. So we've registered these static assets. We could also very easily register this as a collection. So that would be an entire workflow as an asset. So this would then be a hierarchy or tree of different assets. So that could be this entire pipeline would then point to these previously registered assets. So you would click with one button, and you'd be able to purchase the entire workflow. So you get up and running with a starter code, with a trained model, with a notebook, with the data immediately. So that's the current status. So let's look a little bit further into some more recent developments. We know that going back to this first point, which is unlocking data, we know that data is very valuable, and it can also be private. So we need to think about ownership of these things. And of course, in the digital world, we don't have transfer of some physical object. We have the ability to duplicate. And we know this is a huge challenge to, I mean, just look at the history of the internet and things like Napster and BitTorrent. So that is a big challenge. How do you maintain ownership of something? So ownership actually implies the rights. So once you download a data set, you essentially have taken full rights to that in a very real sense, is that you could then, you basically have given control to the person that has that thing. They now have, maybe not the legal right, but they have the ability to take that and do whatever they want with it, right? They could then go on the street corner and sell it on a USB stick. They could put it on BitTorrent. So the ownership of an AI asset or a data set, let's say, or a trained model requires this concept of identity as a first instance. So we need to assign ownership to something. And we also want to prevent the loss of ownership by preventing the escape of the asset. So when we mean escape, that means that the data set is escaped into the internet. So it could be, you'll see it on BitTorrent maybe tomorrow. And then the question is also, how can you share ownership? How can you delegate rights? And this is why we want to use the blockchain. So blockchain has a very, very strict concept of identity. So if you own the private key to that public key, you are that public key. You know, that's the whole point, is you sign that transaction, that means you are who you say you are. So as long as you keep your private key to yourself, that means that you are that identity. The other aspect of preventing escape, we know that this is the key to unlocking this data economy, and that's why we're building this compute to data flow, which I'll again go over in a second. And things like sharing ownership and delegating control can be solved with things like multi-sig wallets. So that means a wallet that requires multiple people to sign off before a certain new right is transferred or granted. So that's another reason why we really believe in making this a decentralized project running on the blockchain. So now going back to a more technical view of how we actually would run compute to data. So actually, you'll recall this previous diagram showed different views of an asset. And now we're going to say, OK, let's make the asset very general. So consider the previous case where I was pointing, instead of this, we saw just a file. And that could be sitting on S3 or IPFS or wherever. But actually, if you consider that it's not really just a file, it's actually a service that you're getting. So the service for the previous case was actually you're getting the service of downloading something. So that's a more dynamic case, right? That's actually an endpoint. But if we consider it that way, if we abstract that, actually you can put a lot of different things behind a service. So that's just an endpoint now. So that could be a lot of different things. Could be, for example, training on a GPU for 2,000 ocean tokens per hour. It could be putting an AI system into production, and then per prediction, per image calculation, you could charge people. So that would be a productionized AI model, and yeah, that would be the idea, and that could be orchestrated with Ocean Protocol. Just instead of a static data set, you could also download some streaming data. So you get the service is now behind Ocean Protocol is now not a static data set, but a dynamic one. Or we could even take it into the federated case where instead of just accessing one data set, let's access 1,000 data sets, which let's say they're the genetic repository for different countries, which is the current case. So it's very difficult to get access to this genetic data. But it's, of course, very interesting if we do have access to these different repositories. So let's train a federated model. And a federated model is the case where you don't have all of the data on your machine in your RAM. What you do is you instantiate the weights randomly, and then you get the weight updates from these different instances. So 1,000 updates, and then you iterate on that process. So that could be 1,000 endpoints behind one asset. So that's, again, the simplified view. So we've just, last week, closed a project with an automotive company in Germany to build this for them. And this was a very interesting project because it's actually key to our roadmap as well. So we have a lot of development in this direction. So we are orchestrating this service with Kubernetes operators in the background. And the general idea is the following. So you would have your Jupyter Notebook starter code coming from the service provider who owns the data set. So you would have an idea of what that data set looks like. You get a sample data set, and that data set could be obfuscated. It could be synthetic. So there's no privacy escape. So you, as a data scientist, would build your script, your algorithm, training pipeline, whatever you want to call it, and you would send it into their premise. So again, they're now the processor for this data. They're running the compute on their premise. On their premise, of course, is the actual data set. They run the model, training script. The model is then trained, and either they give you the model or they put that model up for production, and that's all orchestrated behind on their premise. So there's a lot of different modalities. So on-premise compute, that's the most simple case. Let's talk about also third-party premise. So you'll notice here, actually the private premise, actually they're getting your training notebook. So maybe you have some IP in there that you'd like to protect. Well, in that case, you could do basically a double-blind case where you trust some other third party. You engage in a legal contract with them that they protect your information. And therefore, then we also have something called no algorithm escape in that case. So federated learning is enabled by this. This would be one way to produce, so the production as an asset, productionized model as an asset, so new endpoint being created. Or you could also just download the data, or download the model rather. And there's a lot of other interesting applications here which could really unlock this even into new directions. So homomorphic encryption and differential privacy are all things that we're investigating as well. So this is also, there's a lot of research going on. So one interesting topic, which is just last week, there was a post by our CTO, Trent McConaughey, looking at extending this concept of ownership and assigning ownership to a data token. And that would be a non-fungible ERC721 token. So this is really cutting edge, so I don't know all the details, but essentially the idea is that this single token is then holding all of the rights to that data. And that makes it much cleaner to transfer ownership between different people. If you own the token, then you own the data. And that token can have different attributes assigned to it. Another interesting extension to the Ethereum ERC20 basic token is what's called a composable token. So a composable token is composed of different types of tokens. So you could actually attach different NFT or ERC20, so yeah, different NFTs or fungible tokens. So I'll just, yeah, maybe people don't know this words if you're not in the crypto community. So fungible means, for example, a US dollar is equivalent to any other US dollar. So that's fungible, that's tradable, they're equivalent. But a baseball playing card is not fungible because some of them might have scratches or it might be pristine. And in that case, it is a unique thing. And that's the concept in the blockchain world, is that we have this thing called a non-fungible token, which is unique. So going back to these composable tokens, this could represent the case where maybe you have a pandas data frame for all those data scientists out there. It's a tabular data format where each column could represent different features, and then each row of that table is different records. So it's a database. So you could compose an ERC998, which would hold access. It could hold a portfolio of NFTs, which give you access not to the entire data set, but to a selection of those records. So that is one extension that we're working on right now. OK, so I'll start to wrap up. So I just want to come back to really the key message is that we want to provide this ubiquitous infrastructure, this unstoppable blockchain-powered infrastructure that. So for me, I started in this deep dive into blockchain 2 years ago, and it's really amazing if you think about it. It's something that you can just point to using some standard libraries, and you can start interacting with this code, and it's running on this world computer, this Ethereum world computer. And there's of course other blockchains, and that is really amazing. It's an infrastructure that is extremely reliable. Of course, it's in early days. It's very, very slow. I mean, you have to wait for the transactions, but it's really amazing that you don't need to rely on having like your traditional microservice architecture where things can go down, or you have to rely on Amazon or some other cloud provider. So it's really acting as this ubiquitous infrastructure that you can just point to and connect to. And that's the reason we're really excited about this project, to connect, to enable these problem owners and problem solvers to find each other. So that's the first thing that we have achieved, which is this ability to search this anywhere on the planet. You can then search for different data sets and different static assets and gain access to them. And then the second thing is unlocking access. And that is also enabled by the blockchain by strictly enforcing access control through the protocol itself. And that's enforced by identity and just this decentralized ecosystem. So that's where we are. And then I'll talk a little bit about where we're aiming. So we have deployed to production these different components, which I demonstrated. So on the Ethereum mainnet and our proof of authority network, and these microservices, which are running as a demo again. So we allow you to, today, you can publish a data set into Ocean Protocol. You can set a price, and you can start to receive Ocean tokens for that. So we do have a token. We did an IEO, and that is a tokenized ecosystem. And you could today publish this asset. If you own the private keys to that asset, you own that asset, and therefore you get assigned those tokens through the blockchain. So you could immediately start using that. And we allow this broader scope. So this generalized asset is a service. It's not just a static asset. We allow you to compose assets together. And then the most recent development is what we're calling version 2. It's a Kubernetes orchestrated compute to data platform where you can keep your data on premise, keep it secure, execute the training there, and then send back the results. And of course, you could extend that to many other different things. It doesn't have to be just an AI training. It could be analytics. You could then, if your center of operations is in Germany, but you have a branch as a corporation in China, you can send in the algorithm without necessarily going through a lawyer, as long as they approve the whole process. You could send that for compute there and get back the aggregate results. And that is very, very exciting. So where we're aiming for is going towards this ecosystem, this AI ecosystem. And that's the other reason why we are interested in building this on the blockchain and not on, because of course you could do similar things in AWS. So if Amazon has recently launched a data marketplace, but what's interesting about this is that we want to make it completely permissionless and ownerless. So that means we want to basically take from the Ocean Protocol Foundation, which owns the project now, we want to allow this community to develop and pass off ownership. So the bigger vision is absolutely we want to run this on a decentralized autonomous organization, a DAO, which in the crypto world gets people very excited. But for those of you not necessarily deep into this community, a DAO is a smart contract which is owned by many different wallets. And you can then, as a community, so a wallet is a person, for example, and as a community, you can make decisions about how this DAO operates, the governance structure. Maybe it's a DAO which owns a certain class of assets, for example, the automotive data DAO, which would then enable you to onboard or whitelist different parties and give access on a selected basis. That's the bigger vision. So we do have a huge amount of developer resources. Again, everything is open source on GitHub. We are active on a lot of different channels, so Gitter, and yeah, you'll definitely be able to find us. And we're very excited to collaborate with people. So if you are interested in building a marketplace, if you're interested in contributing in any way, get in touch with me or get in touch with us through these channels. So we're very much looking for people to take this to the real world, to build marketplaces, to act as data providers, and to provide value on this network. So please do get in touch. So that's the bigger vision. So we want to be fully community-owned, permissionless, open source. That's the high-level view of Ocean Protocol, and I'd be happy to take some questions.
Thank you, Marcus. That was a great talk. Can we switch to the Slido slide, please? So great, we already have some questions. Please, if you haven't already, if you have questions, go into slido.com, #WAD2019, and this is the AIM blockchain stage. So shall we answer some questions? I think we have time for about like 3. So the first one, who pays for the infrastructure costs? Who pays the developers and ongoing code maintenance?
So Ocean Protocol Foundation is the owner of this project. They have raised an ICO, if you want to call it an ICO. So IEO is the new ICO. It's where you raise money with a token sale, but it's immediately available on the exchange. They have the mandate as a nonprofit foundation to maintain the protocol itself. So that's what I mean with ubiquitous infrastructure. So that infrastructure, that would be the blockchain nodes themselves that are running proof of work and running the smart, or not proof of work, sorry. That would be the mainnet, the proof of authority network, which is a different type of consensus mechanism. That is you can count on that running. And again, the idea is to onboard different node operators and incentivize them with a token. So that infrastructure is there. And then the real question is who's running the data storage infrastructure. So we support AWS, we support Azure, so S3 and Azure Storage, whatever it's called. And that would be up to you. We're agnostic to that. So we're a protocol. We're not Ocean Protocol is a protocol, and that means you can use that as you wish. So it's up to you to decide what is it worth and what does it cost me to run this infrastructure. So you would need to run this metadata store. You would need to run this access control microservice, and they're very small, small footprint microservices, and the data storage itself, of course, as well. And you could then think, OK, maybe IPFS or something else. But that's up to you as a marketplace or you as a data provider to run that.
Interesting. OK, so the next question, I think, is also related. So can you verify the quality of the data? How do you handle claims?
Yes, very good question. So quality of data is objectively, it's not objective, it's subjective, right? So it's very dependent on what you use that data for. And we can never predict how you will use that data. So from an algorithmic perspective, you can't really verify or automatically verify that. However, there are different ways to curate data. So, for example, in the case of, we did a proof of concept with X-ray images. And the idea there would be to have a community of experts, and that, let's say they're doctors. They would be incentivized, they would be tokenized to validate, and they would then give their stamp of approval and say, yes, this is a valuable data set. We agree that this is actually X-ray images and not something weird. And those doctors would have to have their identity on chain, and they would be whitelisted. That would be one form. The other form could be just the fact that you've downloaded it, you've trained it, and you could upvote or downvote that asset. So that would be another curation mechanism. There are, of course, other ways you could even automate. You could try to automate some of this stuff just by virtue of the fact that this data was actually improving a model. It's not just predicting random noise anymore. It's predicting something. And that would be maybe a more automated way to verify that quality.
Very interesting. And also, if you have further questions, if you feel like it's not answered completely, then also you can always follow Marcus on his social media or come up to him afterwards. He's going to be here around the stage and ask him further questions. One last question. Which one would you like to answer, Marcus?
So developers standing in a company. OK. So the second question, yes, you can.
Yeah.
And the first one, developers sending it. Yeah, so that would be, again, will not be stored. Yes, so that would be this case of no algorithm escape. And that you could solve that in different ways. You could, in essence, it comes down to trust. And that is exactly what the blockchain is. It's a trust machine, right? It enables you to trustlessly execute things. So that's one aspect. The other aspect in this case would be to solve this with a third party. And that would be a double-blind case, so that both of you, so the Jupyter Notebook provider and the computation and data provider would trust a third party to run that. And there are a bunch of different solutions to that. But yeah, good question.
Perfect. OK, and for those of you who didn't realize, Marcus just answered the second question as well. So can I publish my model pipeline, weights, and matrix without the data sets? Yes, you can.
Yeah.
All right, so that was it for today, or for Marcus's talk.
Thank you very much.
Thank you very much.
See you next year.
Yes, exactly. See you next